Hello students, today we are going to discuss class 10 science chapter 1 chemical reactions and equations, and today's topic is changes and types of changes. So the first of all the question arises, what is change? So in simple word we can say when initial substances or the original substances changes into different substance, it is known as change. So how can we define change? An act or process through which something becomes different, or we can say that when there is original substance becomes different, it is known as change. So what are the different types of changes? So already we have discussed in previous classes that changes are of two categories: physical changes and chemical changes. So how can we differentiate between these two changes? So during physical changes, no new substances are formed. That means the original substances remains same. That means there is no changes in their properties of initial substances. That means it remains almost chemical properties remains same. But during chemical changes, new substances are formed and initial substances changes their property. That means a new substance is formed which has properties different from the original substances. That means chemical properties has been changed. So what are the examples of physical and chemical changes? So example of physical changes are boiling of water. Second is melting of ice, and third is tearing of paper. So in case of boiling of water, when we boil water, we can say that there is only change in the state. The liquid water has been converted into gaseous water vapor. In the same way, melting of ice. During melting of ice, the ice has been converted into liquid form, that is water, and during tearing of paper, the size of paper has been changed. Now what are the examples of chemical changes? First is rusting of iron. So during rusting of iron, a new substance called iron oxide is formed, which is totally different from the original substance. Cooking of food. During cooking of food, the properties of food has been, raw material has been changed, and burning of paper. When we burn the paper, we get ash, which has totally different properties from the paper. So now we are going to discuss chemical changes. Now the question is how we are going to identify that chemical changes are occurred. So how we are going to find out कि chemical changes हो गया है. So there are following changes to determine the chemical reaction has taken place. There are few parameters which can determine the chemical changes. First of all, it is change in color. During change of color, the initial substances what we have taken will change their color. As we have seen in previous classes, when copper sulfate reacts with iron, the color of the iron sulfate changes into green. The blue color has converted into green color. Now formation of precipitate. So first of all, what is precipitate? It is an insoluble solids. During reaction, sometimes insoluble solid substances are found in the test tube. There may be change in state. This is very common we see in a daily life. Even we burn wax, then it converts into water and carbon dioxide gases formed. Here we can see that solid wax is first converted into liquid and then in gaseous state. There may be change in the temperature. Either heat is released or heat is absorbed, and evolution of gas. Sometimes gas is also released, as we have seen in case of reaction between zinc and sulfuric acid, hydrogen gas is released. So these are the different parameters. So the chemical changes can be represented in the form of chemical reaction. So now the question arises, what is chemical reaction, or how can we define chemical reaction? So when two or more substances react and form some new substance, it is called as chemical reaction. That means when two or more substances they will combine or react, some new substances is formed, which is known as chemical reaction. Or in the simple language, we can say that chemical reaction is the shortest method or representation of chemical changes. So we can represent chemical changes with the help of chemical reaction. So to represent chemical reaction, we require two things. First is reactants and second is product. So what are reactants? Reactants means the initial substances or the original substances. So how can we define reactants? Initial substances are the substances which take part in a chemical reaction. And what are products? That means the final substances or the new substances produced as a result of a chemical reaction. In simple language, we can discuss that when A and B, two reactants reacts and they form one product which is AB. Here A and B are reactants as they are taking part in the chemical reaction, and AB is product which is produced as a final result. So simple one example of in a chemical reaction is burning of magnesium in the air to form magnesium oxide. Here magnesium and oxygen are reactant and magnesium oxide is product. As magnesium oxide is produced due to reaction of magnesium and oxygen, and magnesium and oxygen are taking part in chemical reaction, so they are known as product. For this, the chemical reaction, the reactants are written in the left hand side, whereas products are written on the right with plus sign between them. The arrow shows the direction of the chemical reaction. So now chemical reaction can be represented in two different ways. We can represent chemical equation either in the form of word equation or in the form of symbolic equation. So what is word equation? In word equation, we write the name of the reactant or we write the word. For example, magnesium react with oxygen, it gives magnesium oxide. We write the name of reactant and product. But this word equation is less informative and we can make it more informative by using the symbolic equation. So how can we write symbolic equation? To write symbolic equation, we use the symbols of different substances. Here magnesium can be written as Mg, then oxygen O2 and magnesium oxide as MgO. So we can write MgO. So we can write in the two form equations can be written in the two form word equation and symbolic equation. But clearly we can see that symbolic equation is more informative and it gives us information. In this case we can see two atoms of magnesium reacts with one atom of oxygen to give magnesium oxide. In this case we can also write the states of substances. Magnesium in the solid state, oxygen in the gaseous state, and magnesium oxide in the solid state. So we can conclude that symbolic equations are more informative. So we generally use the symbolic equation, it is more convenience to write. Hello everyone, today we are going to discuss class 10 science chapter 1 chemical reaction and equations, and today's topic is balancing of chemical equation. A chemical equation can be divided into two types. First is balanced chemical equation and another is unbalanced chemical equation. So what is balanced chemical equation? A balanced chemical equation has the number of atoms of each element equal on both sides. See the example. Zinc plus hydrochloric acid reacts to form zinc sulfate and hydrogen gas is released. In this equation, number of zinc, hydrogen and sulfate are equal on both sides. That is, number of zinc, hydrogen and sulfate are equal in right hand side as well as left hand side. So it is a balanced chemical equation. So another is unbalanced chemical equation. if the number of atoms of each element in reactants is not equal to the number of atoms of each element present in the product, then the chemical equation is called unbalanced chemical equation. If the reactant site number of elements in the reactant site is not equal to the product site, it is known as unbalanced chemical equation. See the example. When iron reacts with water, it forms iron oxide and hydrogen gas is released. So in this example, we can see that number of atoms of elements are not equal on two sides of the reaction. That means the reactant and product are not equal in mass. For example, on the left hand side only one iron atom is present. We can see only one iron atom on the left hand side while three iron atoms are present on the right hand side. So that means number of hydrogen atom is not equal. Therefore, it is an unbalanced chemical equation. So not only the number of iron, number of oxygen is also different in right hand side and in left hand side. So what is the reason for balancing equation? So already we have discussed in class 9th law of conservation of mass. So what is that law? According to the law of conservation of mass, mass can neither be created nor destroyed in a chemical reaction. Student, do you remember the law of conservation of mass? That mass can neither be created nor destroyed in a chemical reaction. So, to obey this law, the total mass of the element present in reactants must be equal to the mass of elements present in the products. That means the mass of reactant side should be equal to the mass of product side. So now we are going to discuss balancing a chemical equation. So how do we balance a chemical reaction? To balance the given or any chemical equation, we follow the following steps. See the reaction iron plus water, how they react and what is formed. So the first step we are going to do, we will make a table and we will write the number of atoms of elements present in reactants and in products in a table as shown here. So first of all, we are going to make a table. We are going to make a table. In that table, we will write the first column will be name of atom and second column will be of number of atoms in the reactant and the last column will be number of atoms in the products. So here the name of the atom is iron. Number of atoms in the reactant side, it is 1 and products it is 3. Next is hydrogen. Number of atoms in the reactant side, it is 2 and number of atoms in the product side, it is 2. That means hydrogen is balanced. And for third one is oxygen. Number of atoms in the reactant, it is 1 and in the product it is 4. So first of all, we will start with the balancing the atom which is maximum in number. First, we have to start the balancing the atom which is maximum in number on either side of a chemical equation. Which is maximum on either side of a chemical equation. So in this equation, the number of oxygen atom is the maximum. It is very clear that number of oxygen atom is the maximum on right hand side. So to balance the oxygen, we need to multiply the oxygen on the left hand side by 4. As on the reactant side only one oxygen atom is present, so we are going to multiply by 4. Why we are going to multiply by 4? Because the number of oxygen atoms becomes equal on both sides. So what is the first step? We are going to multiply water by 4. So the number of, now after first step, now the number of hydrogen atoms becomes 8. As we multiply water by 4, the number of hydrogen atoms becomes 8 on the left hand side. So now the oxygen becomes 8 on left hand side, which is more than that on the right hand side. To balance it, we need to multiply the hydrogen on the right hand side by 4. So to balance this, we are going to multiply hydrogen on the right hand side by 4. So see the second step. Here we have multiplied hydrogen by 4. After the second step, the number of oxygen and hydrogen atoms becomes equal on both sides. So after multiplying, the number of oxygen and hydrogen becomes equal on both sides. The number of iron is on the left hand side. The number of iron is 1 on the left hand side, and it is 3 on the right hand side. So we can see that number of iron is 1 on the left hand side and 3 on the right hand side. So to balance it, we will multiply the iron on the left hand side by 3. So step number 3, we are going to multiply iron by 3. So now the number of atoms on each element becomes equal on both sides. Now both sides, the number of atoms on each element becomes equal. Thus this equation becomes a balanced equation. Now we are again going to make the table. Same table will be made. The name of the atom, again number of atoms in reactants and number of atoms in the product. Now we can see that iron, both sides, right hand side and left hand side, number of atoms are 3. Hydrogen, right hand side and left hand side, number of atoms are 8. And oxygen, right hand side and left hand side, it is 4. So after balancing, we can write the reaction. Thank you. Hello students, today we are going to discuss class 10 science chapter 1 chemical reactions and equations, and today's topic is types of chemical equations. So today we are going to discuss different types of chemical reactions. So what are the different types of chemical reactions we are going to study? The number 1 is combination reaction, second decomposition, displacement reaction, double displacement, and oxidation and reduction. So here we are going to start with the combination reaction. As it is clear from the name, combination means when the reactants combine. So how can we define combination reaction? When 2 or more reactants react to form a single product. When 1 or more reactants, they combine to form single product. See the example. When 2 reactants, that is A and B, they react, they form AB. And when 3 reactants, that is A, B and C, when they react, they form ABC. In both the cases, the reactants are combining to form a single product. So now we are going to discuss few examples. The first example is of burning of coal. So when carbon burns in the presence of oxygen, when carbon combines with oxygen, it forms carbon dioxide. Here also carbon is combining with oxygen. They both are combining to form carbon dioxide. Second example is formation of water. During formation of water, hydrogen reacts with oxygen. They both combines and form water. And the third example is calcium oxide, which is also known as quicklime. Calcium oxide is known as quicklime when reacts with water, forms calcium hydroxide, which is also known as slaked lime. Calcium oxide is known as quicklime and calcium hydroxide is known as slaked lime, and heat is produced. So this combination reaction can be between element and element, between element compound, or between compound and compound. So the first example of burning of coal is an example of reaction between element and element. Here carbon and oxygen both are element and they combines to form carbon dioxide. Second example of element and compound. So carbon monoxide, it is an compound and oxygen is an element. They combines to form carbon dioxide. Third example of compound and compound. The example of calcium oxide with water. Both are compounds and they form calcium hydroxide. One more example we can take when water combines with carbon dioxide. Both are compound, it forms carbonic acid. So this is combination reaction when two or more reactants react to form a single product. Next we are going to discuss decomposition reaction. Decomposition means breakdown or to decompose. So how can we define? It is a type of reaction in which a reactant break up into its constituents either by heating or passing current or in the presence of light. That means all decomposition reaction requires or involve heat. That means to decompose they require heat. So see the example when AB is a reactant when it decomposes it forms A and B. In the same way when ferrous sulfate is heated it forms ferric oxide and sulfur dioxide and sulfur trioxide gases are released. So on the basis of the type of heat involved, which type of heat is involved, decomposition reactions are again subdivided into three categories. So the first category is photo decomposition. Photo means light, breaking in presence of light. So when decomposition is carried out in presence of sunlight, it is known as decomposition reaction. So when breakdown occurs in the presence of sunlight, it is known as decomposition reaction. Here we are going to discuss two examples. First is when white color silver chloride is exposed to sunlight, it forms gray color silver and chlorine gas is released. And in second case, when yellow color silver bromide is exposed to sunlight, gray color silver and bromine gas is released. Both the reactions are very important as these are used in black and white photography. Second category is electrolytic decomposition. Electrolytic means breaking by passing electricity. So when breakdown is done by passing electricity, it is known as electrolytic decomposition. So when decomposition is carried out by passing electricity. The first example already we have discussed in previous classes. So when electricity is passed through water, it produces hydrogen and oxygen gas. Activity have discussed in class 8th. What happens when electricity is passed through water. Second example is aluminum oxide. When electricity is passed through aluminum oxide, aluminum and oxygen gases are released. And the third example is of thermal decomposition, where decomposition is carried out by heating. That means when heat is provided, there is decomposition reaction. So when decomposition is carried out by heating. Here the example is when AB is heated, it forms A plus B. See the example when limestone, which is calcium carbonate. Calcium carbonate is also known as, children, limestone. When it is heated, it forms quicklime. Quicklime, another name is calcium oxide. Very good. And carbon dioxide gas is released. When copper carbonate is heated, black color copper oxide and carbon dioxide gas is released. So next we are going to discuss about the displacement reaction. This is not the new reaction. Already this reaction we have discussed in previous classes. So what is displacement reaction? It is a reaction between element and a compound in which a more reactive element displaces less reactive elements from its compound. That means the element which is more reactive displaces the less reactive element, but less reactive element cannot displace more reactive elements. See the examples. When A reacts with BC, it forms B plus AC. Here we can say that A is more reactive than B. So it displaces B from its position and takes its position. When iron reacts with copper sulfate, it forms iron sulfate and copper is released. This reaction or activity we have already demonstrated in the previous classes. When blue color copper sulfate was taken and iron was added, the solution was changed to green color due to the formation of iron sulfate and copper was removed. Next example, when zinc reacts with copper sulfate. As zinc is more reactive, it displaces copper from its position and forms zinc sulfate. And the last reaction is when copper reacts with zinc sulfate, no reaction will take place. So what is the reason behind? Can you guess, students, what is the reason behind? The reason is that zinc is more reactive than copper, so it cannot displace copper from its position, so no reaction will occur. Next is double displacement reaction. As the name suggests, there is twice or double displacement. In double displacement reaction between two compounds in which they mutually exchange their ions. The reaction takes place between two compounds and they exchange their ions. See one simple example. When AB, one compounds react with CD, another compound, it forms AD plus CB. Here it is very clear that A combines with D and B combines with C. Both the compounds have exchanged their ions. One more example is there. When sodium sulfate Na2SO4 reacts with barium chloride BaCl2, it forms barium sulfate BaSO4 plus sodium chloride. So there is also exchange of ions. So depending upon whether precipitate is formed or not, double displacement reaction is classified into two categories. First is precipitation reaction and second is neutralization reaction. So precipitate, already we have discussed in the beginning of the chapter what is precipitate. It is an insoluble solid that emerges from a liquid solution. So what is precipitation reaction? So when during double displacement reaction precipitate is formed, it is known as precipitation reaction, or the reaction in which two compounds mutually react and leads to the formation of insoluble solid substance called precipitate. See the example. When lead chloride reacts with barium iodide. When lead chloride reacts with barium iodide, it will form a precipitate of yellow color. Precipitate of yellow color, lead iodide and barium chloride is formed. Second category is neutralization reaction. Do you remember neutralization reaction? We have done in class 7th. When acid reacts with base, it forms salt and water. Or a reaction in which two compounds react to form neutral substance by exchange of ions. Here we can say take an example of hydrochloric acid and sodium hydroxide. Sodium hydroxide is a base. When they react, they form salt, sodium chloride salt, which is neutral, and water is produced. Next is oxidation and reduction reaction. So first of all, we are going to discuss oxidation reaction. So what is oxidation reaction? In oxidation reaction, there is addition of oxygen or removal of hydrogen. That means either there is addition of oxygen or removal of hydrogen. We can call it oxidation reactions. See the examples. In the first example, already we have discussed this example many times. When magnesium reacts with oxygen, it forms magnesium oxide. In this example, magnesium is combining with oxygen. That means there is addition of oxygen. So oxidation is taking place. Second example, when zinc combines with oxygen. Here also there is addition of oxygen. So this is also oxidation reaction. And the second case is removal of hydrogen. So for that we are going to take example of sodium hydride, NaH. When it decomposes, it forms sodium and hydrogen. This is also oxidation. Can you guess? Yes, as hydrogen is removed. So removal of hydrogen is also known as oxidation. So it is oxidation. Now we are going to discuss reduction. What is reduction? This is totally opposite of oxidation reaction. Here there is addition of hydrogen. Here hydrogen is added and oxygen is removed. Now we are going to discuss. First case, sodium plus hydrogen. Here hydrogen, there is addition of hydrogen. When sodium reacts with hydrogen, it forms sodium hydride. As there is addition of hydrogen, so it is known as reduction. Second case is removal of oxygen. See the example of magnesium oxide. When magnesium oxide breaks, it forms magnesium and oxygen. Here there is removal of oxygen. Magnesium oxide removes oxygen and forms magnesium and oxygen. So it is reduction reaction. So now we are going to discuss redox reaction. So what is redox reaction? The reaction in which oxidation and reduction occur simultaneously. The reaction in which oxidation and reduction takes place at a time. That means both the reactions are taking place at the same time. So now we are going to discuss one example of redox reaction. So example we can take of copper oxide reacts with hydrogen, it forms copper and water. So how it is redox reaction? In this reaction, copper oxide is changing into copper. Oxygen is being removed from copper oxide. We can see that oxygen is removed from copper oxide. As we know that removal of oxygen from a substance is called reduction. So copper oxide is being reduced to copper. So reduction is taking place. But hydrogen is changing to water. In second case, we can say that hydrogen is changing to water. Oxygen is being added to hydrogen. Now there is addition of oxygen. So addition of oxygen is oxidation. So hydrogen is being oxidized to water. So at the same time, oxidation and reduction reactions are taking place. So it is known as redox reaction. So now we are going to discuss another topics, that is oxidizing agent and reducing agent. So what is oxidizing agent and what is reducing agent? So oxidizing agents are those which oxidizes other and itself gets reduced. That means which oxidizes others and itself get reduced. And reducing agent are those which reduces others and itself gets oxidized. We are going to take the same example of copper oxide plus hydrogen. It gives copper plus H2O water. Here we can say that copper oxide. Here oxygen is removed, so reduction, so it is an oxidizing agent. As oxygen is removed, so reduction, and it is an oxidizing agent. And in second case, hydrogen water is added, so oxygen is added. In hydrogen, oxygen is added, so it is oxidation and it is behaving as reducing agent. So what are the different effects of oxidation in daily life? So oxidation reaction affects our daily life. So how does it affect our life? Here we are going to discuss two important topics. One is corrosion, another is rancidity. So corrosion we have already discussed in previous classes. When a metal is exposed to substances such as moisture, air, water, acid, etc. for some time, a layer of oxide is formed which weakens the metal, hence metal is said to be corroded. That means when metal is exposed to moisture, air, water, something else, a layer of oxide is formed and it becomes corroded. So day-to-day examples are rusting of iron, black coating on silver, and green coating on copper. These are the day-to-day examples. So what can we do to prevent corrosion? So we can do painting by lubricating by using grease or oil, galvanization by coating zinc layer, by electroplating. Already electroplating we have done in previous classes. We have demonstrated the activity of electroplating and alloying. Another important effect of oxidation in daily life is rancidity. This is a new term for you. So the oxidation of food, that is fats and oils, when comes in contact with air. That means when fats and oils comes in contact to air, oxidation of food takes place, due to which food starts smelling bad and taste bad. So how can we prevent rancidity? We can store food at low temperature, we can add preservative, that is antioxidants, by storing food in airtight containers, flushing out air with nitrogen. We have seen that chips packets are filled with nitrogen gas. Which gas? Nitrogen gas. Can you guess why? As nitrogen gas prevents rancidity. As nitrogen gas prevents oxidation of food. So chips packets are flushed with nitrogen gas. So the last topic of the chapter is chemical reaction on the basis of temperature. So on the basis of temperature, we classify reactions as exothermic and endothermic reaction. So reaction in which heat is released along with formation of product is called exothermic reaction. So here we can see the example. When methane burns in the presence of oxygen, it forms carbon dioxide gas, water in the form of water vapor, and heat is released. That means heat is released along with the products. So when there is release of heat, it is known as exothermic reaction. And second is endothermic reaction. The reaction which requires energy in the form of heat, light and electricity. That means although that reaction which involve heat, which requires heat. So all the decomposition reaction, do you remember decomposition reaction? All decomposition reactions require heat. So the examples are decomposition reactions.